Hello, my name is David Brown. I am a principal solution engineer with Couchbase, and I'm going to present a session on JSON data modeling for project success and performance. A little later on, we'll be joined by Tyler Dendon, who is a solution architect, and he's going to give us a little demo. But let's get on. Here are the things we're going to talk about. We're going to talk about the different challenges that you face when data modeling, some of the tools that are available in JSON and Couchbase to deal with those challenges. We'll look at JSON as a document structure and what the things that are in there that can affect how we model our data. Then we'll talk about how we design what data goes into what objects or the object model. Then we'll do a little discussion on indexing and the choice between GSI and FTS. And that's where Tyler's demo will come in. And then at the end, we'll have a quick note about what to do if you make some mistakes and your data model isn't working properly, as well as a summary and a wrap up at the end. So let's get to the challenges and the tools of data modeling. So data modeling involves a lot of choices. Each choice represents an optimization of sorts. The act of optimizing for one goal in most cases will mean that you have to de-optimize for some other goal or goals. When you go to your end users and ask them what they want to optimize, you're often going to find it difficult to nail them down to one thing. They're going to want the top performance, but they won't necessarily want to pay for the resources to achieve that performance. I don't want to dissuade you from asking them though and getting them to commit to one thing on paper because that might help avoid some arguments in the future. What we're going to teach you today is a number of dials that you can adjust when you are designing your data model, and hopefully you can take this knowledge and apply it to your own situation. There is no single right answer or no single right data model, although we will try to show you that there's some things that you shouldn't do or you should avoid. Please be warned, we will be making recommendations that will seem to contradict each other. That's just evidence that optimization of one goal implies de-optimization of another goal. So here are some of the main challenges that you face when architecting an enterprise system. We won't go into them in depth here, but just the highlights. Generally, our recommendation is you should always start by determining what the service level agreements need to be for your system. If you're off by an order of magnitude in your SLAs, your capabilities, you're probably looking at a complete rewrite. Don't forget to consider network latencies in that calculation. So you should be defining SLAs both from the client point of view and from the server point of view so that any difference in the middle is at least allowed for and accounted for and identified for where that problem belongs. It's important to start off with a good estimate of the overall system cost up front, including hardware, software, and ongoing support costs. No one likes to get surprises here, neither the customer who has to pay the bill or the developer who finds out too late that they're over budget. One common mistake here is to ignore the external costs involved, such as the cost of missed SLAs or damage to the company brand from a system downtime, or the number of people that it takes to support the project. It's always best to have a properly sized environment to run your system in. That's an investment that in the long run will always help you. And we at Couchbase are always here ready to help you come up with those initial sizing estimates in the beginning of your project. One thing that us clever humans have yet to fix is the speed of light. So despite ever improving hardware, network bandwidth is often the bottleneck. So we have to continually consider how much data we're moving around, not just between the client and server, but between the servers themselves in order to keep data replicas in sync. And how you design your data model is going to have a big impact on how much data is moving around. Don't ever forget as well about the data egress costs from cloud environments. If your servers are in the cloud and your clients are outside of the cloud, take that into consideration because that's a bill you don't really want to get down the road unexpectedly as well. Cache invalidation. So along with property naming things and off by one errors, cache invalidation is one of the two hardest problems in computer science. Fortunately, Couchbase's memory-first architecture renders this problem moot. In Couchbase, all operations go through the memory layer first, so you never have to worry about getting stale data out of the cache or trying to come up with eviction policies or deciding when to invalidate data in the cache. Because everything goes to the cache. So that's a problem we have solved for you. And then also architectures that are dependent on multiple connectors or batch processes to synchronize data between multiple systems are notoriously complex and brittle. This is another problem that Couchbase kind of solves, and a place where it shines. It's not that we don't have connectors to other systems. We absolutely do. If you need them, they're there. But with our multi-service architecture, we can implement near real-time analytics and provide kind of the clients the ability to immediately query based on their own rights without any external processes to manage, to configure, or to maintain, or to go down or to break. So we've got some of the problems solved for you. Speed of light, we can't solve even if we tried. Okay, so let's look at some of the tools that Couchbase provides as well to solve these remaining problems. While this is not the topic of this presentation, Couchbase, thanks to its NoSQL core, provides linear scalability by adding commodity hardware. This will certainly play into the SLA versus cost question, but at least it's good to know that adding resources will generally solve many of the performance problems you may encounter down the road. It's kind of like a safety net. Selective denormalization. In relational databases, every one-to-many relationship needs to be broken down into separate tables, and then that relationship gets recreated at runtime via joins. That's not true with JSON data stores, and we're going to go through an exercise later on this session which talks about how to do that and gives you an example to understand what we mean by there. And then for the last three, when I first heard someone describe NoSQL as not only SQL, I thought they were just backpedaling from the not SQL definition. But now I think I know what they meant. When I grew up, all phones had rotary dials on them. There's only one way to make a call. But now with these little computers we carry around in our pockets, there are many ways of making calls. I can dial somewhat traditionally using the keypad. I can go to my contact list and press on a contact. I can click on a press to dial URL that comes down with a web conference and the phone knows what to do. I can have apps that directly initiate phone calls directly as well. So there's many different ways to achieve the goal, and you choose the one that's appropriate. Couchbase is the same way. We've got a number of different services, each with their own features and SLA profiles. And the lesson we want to get across here is you want to think about using them all in their architecture. While you can do almost anything through SQL, that may not be the right choice to do it. There may be better ways to do that. So if we take a quick look at the performance profiles of the various different services, we see the fastest is obviously key value, and it runs somewhere between 50 microseconds to 100 microseconds. Depending on your network, it might be a little slower, depending if you have to go to disk to get the values because you're falling out of your cache. It might take a millisecond. But the thing about key value services, you have to have the key to get the value. So unless you've got that thing, you can't find the record. With proper design and adequate resources, SQL queries will generally take a handful of milliseconds. This service, however, is best used for a priori queries. Those are the queries that you already are expecting from your clients. They're also the type of query where you're trying to find a few documents that meet a criteria out of millions or billions of candidates. But again, you're just returning a handful, a very small amount of data. That's what the NCL service or the SQL query service is meant to do. Full text search, not quite as fast as NCL, but also very, very fast. It's a fairly misunderstood service. Depending on the nature of your data and your query, it may be able to run faster than SQL as a search, particularly for fuzzy or like queries. I want you to think of full text search as another tool in your belt to solve your problems. As far as analytics goes, we're not going to cover that here, so please plan to attend some of our other sessions on Couchbase Analytics at Connect. This service is designed for the ad hoc queries that business analysts or data scientists will make on the system. Analytics runs on a separate set of hardware with its own set of data storage so that any queries or long-running queries or high-intensive queries have no ability to impact the finely tuned SLAs of the front operational end. Right? So those are kind of the performance characteristics of those services. So let's go deeper into the structure of JSON. and learn how your design choices can impact system performance. There are a couple of other excellent sessions on JSON data modeling as part of Couchbase Connect 2020. If you aren't familiar with JSON, I would suggest you go and look at some of those. They are meant to be beginner level sessions. We're going to assume that you're familiar with JSON for the purpose of this session. For those of you that aren't and don't want to go pause and go watch another introductory session, the key point here is that JSON documents can embed subdocuments or arrays of primitive values or arrays of subdocuments. And we're going to take heavy use of that capability. And in any key value system, each document will have an associated key. We call it the meta ID that is stored outside of and independently from the document. It's not contained in the document unless you put it there, and generally you shouldn't. But it's kept separate. We're going to talk about how to design that key a little bit. So what choices do we have when we want to do design? Well, if you remember high school English class, and they would make you point out when the author was foreshadowing things to come, well, if you never thought that you'd use that skill in real life, here you go. Here's some foreshadowing. This is what we're going to talk about. For the sake of time, we're going to go into the details. So, attribute names. Let's talk about what your choices are. So perhaps the most important, but also one of the hardest to get right, is to keep attribute names short. Let's consider the choice between naming an attribute geo versus coordinate. The latter is 8 characters longer than the former. Remember that Couchbase is schemaless. There is no requirement for documents to be homogeneous within a bucket or a collection. And so for each document, we need to store all of the attributes along with the data. So if the attribute name is 8 characters longer than it needs to be, and we have 1 billion documents, just storing the extra 8 characters from that attribute name will take up 8 gigabytes of memory and disk. Now, memory is cheap these days, but not so cheap that we can be casual about 8 gigabytes. In an apparent contradiction with my previous statement, I'm going to advise you to make sure your attribute names are human readable and meaningful. One of my customers took the previous advice too far and started naming their attributes A1, A2, and so on. Don't do that. Remember how I said that properly naming things was one of the hardest things to get right in computer science? I wasn't kidding. It is one of the biggest challenges. Always try to be consistent. You won't believe how often someone is going to try to guess the right attribute name, maybe from memory. Try to establish and maintain a corporate-wide standard for attribute names and what they mean. Developer time is cost. Mistakes and bugs cost money. This is an easy place to reduce costs so that you can afford some nice hardware to run your system on. It's a best practice to use plural names for arrays while using singular names for single entries. These kinds of mental hints make programming easier and can reduce bugs. And lastly, in Couchbase, you should avoid special characters, except the $ and underscores in your attribute names. This is mostly because these characters can have other meanings, such as the dash being interpreted as a minus in the SQL engine. Avoiding these characters in your attribute names will eliminate the need to escape your names with backticks later. This applies to the names of buckets, scopes, and collections as well. You'll notice in our example, our travel dash sample bucket. Every time you use that, you've got to put backticks around it because of the dash in the middle. Okay? Another example of making a decision at one point and how long that will continue through. Also, for legacy reasons, Couchbase Mobile used attributes prefixed with underscores as a special document. So even if you aren't thinking about using mobile today, it's best if you can avoid beginning your attribute names with underscore to prevent any potential collision with that feature in the future. So this is the point that's going to be hard for many people to put this into practice, even when they're experienced Couchbase users. Tyler. It's important to standardize on which popular case format you want to use for your multi-word names. And I'm sorry, but in this case, there are wrong and mostly wrong answers. Don't use kebab case. As I mentioned a second ago, that dash will be interpreted as a minus by the SQL engine. If you use this case, you're going to become very familiar with the location of the backtick key on your keyboard. And that's probably not one you're used to using. I would recommend avoiding snake case as well, although this one for less severe reasons. Here, the underscore is just an extra character which takes up space and doesn't really add anything. The winner here is camel case, mostly because it doesn't have the problems of the other two, but not at all because the camel is the mascot of my fantasy football team. I personally like it because it annoys Tyler, who's a longtime Python programmer and just can't stop using snake case. It's likely that you're going to want to have some metadata in your document to capture created by, schema, modified by. This is information about the document that's separate from our metadata. Firstly, the recommendation is to keep your metadata in a single subdocument, not distributed throughout the whole document, mostly because you're going to want to see all those things together. And also because you may end up using some of the subdocument mutation APIs in order to update those things from some of your systems. Also, please don't call this document meta. Sorry, we've already used that word. And again, doing so could have a potential to confuse the SQL engine. I personally like to use the attribute named doc for my metadata document because it reads well when you use the dot notation in your client code. So doc.type, doc.schema makes a lot of sense. And it's only 3 characters, so it doesn't take up a lot of space. Again, avoid using underscores for metadata, mostly because the potential conflict with mobile. Hopefully this is a restriction that goes away in the future, but again, it's an example of a design decision that stays around and is going to have implications for a long, long time. So you have to imagine that your decisions have similar longevity in your system. And on the topic of metadata, please note that the only piece of Couchbase metadata, which is our document metadata, that you should ever use directly is meta.id. You will make use of the other metadata like the CAS value, the compare and swap value, but please only do that via the client APIs. They're designed to decode and update it properly. Okay, so it's hard to imagine a JSON document without some timestamps in there somewhere, so let's look at a few options. First, let's consider the trusty standard ISO 8601 string. It's certainly human readable, it's easy to sort, but it's horribly space inefficient. It's a big long string, and it's difficult to query or index on the component parts, such as the month or the year. You have to put in a bunch of regex statements to pull those things out. Another option would be an array of values representing year, month, day, etc. This is also easy to read and super easy to query and index from those components. But it does require a bunch of code to convert a timestamp object into this structure and to convert it back into a timestamp for your client. And that conversion code would have to be consistent across your entire enterprise. Also, everyone would have to agree on the order and meaning of the components. Being Canadian, it's obvious to me that the order should be year, month, day, but somehow that just doesn't jive with Americans. Don't even get me started on the metric system. So that leaves us with epic representation. This is wonderfully space efficient because it's a single integer. And while it's not human readable at all, it's also not so hard to determine if one timestamp precedes or follows another, which is the most common comparison you need to make visually. The biggest problem is that it doesn't on its own imply a time zone. So just use UTC everywhere. Unless you live in Newfoundland, in which case you want 30 minutes before UTC just because you're from Newfoundland. Okay, here's some more foreshadowing for you. In a few slides, I'm going to teach you that the best way to optimize a SQL join is to not do the join in the first place. This slide has a similar lesson. That lesson, simply put, is that the most space efficient way to store a default value is to not store a default value. First, let's look at the SQL++ language constructs that help you deal with empty or missing values. One option is to query whether the attribute is valued or is not valued. Please note that this is different from is missing or is not null. Now, the clever amongst you are thinking that there's a potential for overlap in the meanings of these 4 different things, 8 different things, 6 different things, sorry. And you'd be right. Personally, I have to open up the docs every time I use these things because I want to make sure I'm using exactly the right one in the right situation. So just open the docs. But if you do need a short answer, I find that the usage of is not valued is probably the most common because it returns true if the value is missing or null. So it's easy to use inside of syntax. Semantics aside, the lesson here is don't store a shipping address that's the same as a billing address. It just takes up extra space. Only store the shipping address if it's different than the billing address. Now, as promised, I'm going to violate my own suggestions in a minute, and I'm going to keep a copy of the shipping address in a transaction or order object because that will capture the shipping address at the time of the order. That's a different thing. But if I'm designing my user profile document and my users are typically end consumers, I can save a lot of space by having my client code assume the shipping address is the same as the billing address unless I specifically design or define a shipping address. This would apply to a default or initial value like a 0. Storing a 0 doesn't take much space, but avoiding storing the attribute name across millions of documents, could make a big difference. And for our last topic on managing space, let's have a quick talk on designing document keys. There are generally two kinds of keys. Keys that can compose data, that you can compose from data that we already know, and keys that are generated and often somewhat random. We should always try to go for a deterministic key where possible, but it takes a little more thought. Remember how we talked about how fast the key value APIs were? Well, when designing document keys, we want to think about what information the client might already have that would enable them to go directly fetch the document. For example, if we're at a login screen and you want to validate the password or fetch the user profile document, it's a good assumption that the client code will already have the user ID, which may or may not be the email address. Using the user ID as the key for the document means that we can fetch it without doing a SQL query. Now, that wouldn't necessarily be a slow SQL query, but a key value will be faster, so why not use it? If we end up mixing document types together in a bucket, we will probably want to compose our key by composing a type prefix with the value that the client already knows. These component parts will have to be separated by some sort of delimiter. The choice of the delimiter is up to you, but we've already covered some of the key criterion, such as keeping the delimiter short, so 1 colon instead of double colon, or avoiding special characters. Another issue is that we want to avoid any characters that might end up showing up in our constituent parts. The example is for an email address, we wouldn't want to use a dot or period or an @ sign as our delimiter because it could get confused with the elements of the email address. Please avoid using any personally identifiable or sensitive information in a key. Couchbase has a log redaction capability that will prevent that information from being sent to us as part of any support ticket. But as a designer, you should consider how many places your other developers might write a key to a log and how that could lead to some sort of information breach. So don't use PII in keys. If you can't come up with a deterministic key, which does happen more often than you might think, you'll need a generated key. For these, please try to use the atomic counter feature in Couchbase to issue a unique integer for your key. Avoid using GUIDs, mostly because they're just simply large character strings and very, very big. Alas, if you're using our cross data center replication feature and have multiple data centers in an active-active configuration, you'll need to prefix your counter ID with some ID from the system in which the counter was issued because counters aren't unique across XDCR. That's not all that hard, and it also mimics the way a lot of things work in the real world, like credit card numbers. The first 4 numbers are going to indicate the company that issued the credit card, and they're always the same for that company. Okay, so I imagine you're thinking, this isn't what I was expecting in a data modeling lecture. But just think about all those little good nuggets of information you would have missed if this was a traditionally modeling session. But just so you don't feel slighted, let's move the conversation towards how documents relate to each other in Couchbase and how that affects your design. If you've ever used a product like Angular or written RESTful microservices, you will understand how Json is awesome at representing data that's tailor-made for the client in a single context. If you're trying to display an order document on a web page, it's best to have a single JSON document that follows the flow of that page to build that page. One of the things I like about our SQL engine is that you can control the shape of the result object, even if that is different from the way the data is stored in the database. But I digress. In a relational schema, every one-to-many relationship needs to be broken down into multiple tables and reconstructed with a runtime join. If there's any variability in the schema, such as the way a credit card payment would have different information than a PayPal payment, the relational schema is going to get complex very, very quickly. We don't have these problems with JSON because it's a flexible schema. One of the first things to think about when you're designing your documents or your objects is the nature of one-to-many relationships. Is this relationship that you're looking at an ownership relationship or not? Will the other documents reference the child document, or is the child document meaningless outside of the context of the parent? Let's go to an example. So here's a diagram that relates the attributes in a customer order line item product kind of scenario, although I've changed the names to tweak it a bit in order to match Tyler's demo. Our task is to decide which elements and attributes end up in which documents. So let's start with the easiest choice, products. The product document needs to be on its own because it's shared by many, many different transaction items. The relationship between the transaction item and the product is not an ownership relationship. By that logic, transactions and transaction items should be in the same document. It doesn't make sense to have a single transaction item out of context with the transaction itself. The only time you might change that decision would be if we anticipated that the cumulative size of all the transaction items would get so large that we couldn't contain them in a single document anymore, or that the size of that document would be prohibitive to move around our networks quickly. It's unlikely to be the case, but it could be in yours. And the same can be said about payments. There'll usually only be one, maybe two or three. Keeping this data within the transaction document can significantly reduce the number of calls you need to go out and fetch the data. So don't just get the transaction and then get the payments, you just get them all at once. It's much faster, much more efficient. Again, the fact that JSON allows us to represent multiple payments of potentially different types in a single document is a key to being able to do this here. And so by that logic, maybe it makes sense to embed all of the transaction documents into our user document. But here's where my spidey senses start to tingle for a few reasons. In this case, we run the risk of bloating our user document. And in some situations where the user may be a corporation and not an individual person, we have to think about concurrent modification or concurrent updates and the possibility that there be multiple concurrent transactions happening for a single user. That would complicate our code. Also, there may be other things that the user does other than transact orders. So we don't necessarily want to clutter up the user document with just transaction stuff when the user may be doing other things as well. So for these reasons, it seems that the best choice is to leave the user as a separate object. And now that we've made the decision of the core document structure, we can fix up the attribute relationships. An ownership relationship, let's see here, oops, let's go back. An ownership relationship, like the transactions and its items, will get converted into an embedded array called items. We'll do the same thing with our transactions and the payments. We'll convert that to an embedded array. For our non-ownership, non-embedded relationship between the transaction items and their associated product, we'll need to add an attribute for the product SKU in our item document. Later, we're going to use a join to recreate this relationship, but only if and when we need it. Stay tuned for more about that. Joins aren't inherently bad, particularly if, as in this case, the size of the data set on the right-hand side is small or manageable. And you can imagine that the number of products or SKUs in any system is going to be a reasonable number. So my advice isn't to avoid joins. It's just, well, avoid joins when it makes sense. For our user to transaction relationship, we're going to do the same. We're going to add a user ID to the transaction document. And we might also consider adding a transaction array or a list of transaction IDs, not the transaction objects, but the IDs in our user document. Okay? But that actually would be a bad idea. Partially because then we'd have to be worrying about the possibility of concurrent modifications to the user document if more than one transaction happened at the same time. But the biggest reason is that we don't need to do this because the global secondary index will effectively maintain this list for us. And using the query and index system, we can get back that list almost immediately. So by using GSI to maintain those relationships, we don't have to worry about bugs in our code that are not updating the array and all the edge conditions and things that could happen there. So think about GSI as part of your model and the way that it is managing and storing relationships as part of one of the tools in your tool chest. Our next topic is something I call selective denormalization. That same power to decide based on our application's need, which elements belong to which document, can be skillfully used to avoid unnecessary queries. This slide basically says relational bad, Couchbase good, and since I'm sure we can all agree to that fact, let's proceed to the example. For our first act of selective denormalization, let's make a copy of the product name in the transaction item subdocument. Yes, this increases storage requirements, and I did just spend a lot of time teaching you that wasting storage was bad. But let's think of the case where a web page is displaying a transaction. All of the information that we're likely want to display on that page is in the transaction document, except the product name. People don't remember products by SKUs. So by copying the name into the transaction item subdocument, we can avoid either the join when we go to fetch the document or a subsequent query to go and fetch the product name from the product document. As I alluded to earlier, the best way to improve the speed of a join is to not do the join in the first place. So what happens if the product name changes? Well, that's probably not allowed or not likely, and if it does, it's probably best from the user point of view to preserve the name of the product at the time of purchase, understanding that we still have the SKU, we can still do that lookup at any time. If we need to get the current name of the product, we have that information, we can do a join at that point or a lookup. For our next trick, we're going to also copy the product category and brand into the transaction item object. We'll do this because we're anticipating the type of analytic queries that will be performed. And we shouldn't anticipate everything. We should know ahead of time that these are the kinds of queries that they're going to run. But my gut's saying we're going to do this. If we think about how the global secondary index might be used to create it against transactions, we would likely include brand and or category as some of the index fields, allowing us to efficiently filter the transaction items based on those categories. If we can do this without a join, we can make our SQL queries very, very fast and make our end users very, very happy. Categories and brands are likely to be short strings anyway, so I'm guessing this is probably a good space for performance trade-off, which is what you do. That's your goal as data model. Next, we'll add an extended price attribute to our transaction document. So this number is simply the sum of all the unit prices multiplied by their quantity, and added them all up. This is probably a number that we would display every time we display the order. So instead of calculating it every time we need it, which wouldn't be too horrible, we can calculate it every time items are added or removed from the transaction. The best way to do this is with an eventing function running on the server. They're very fast and they avoid having bugs in client code that might forget to update that number when they're making changes to the items. Be sure to catch some of the sessions on Couchbase eventing here at Connect. I'm pretty sure you're going to like it. One of the most common problems that Tyler and I have encountered in the field is the misuse of arrays. This could be partially because both our SQL language and our client SDKs have numerous functions and APIs for manipulating arrays. Honestly, we make it too easy to use arrays. But we also think this mostly happens because people try to recreate mini databases inside of their documents. And we're here to tell you to resist that temptation. If you have items that have some intrinsic and important order, then arrays are probably the right choice. They're the only feature that naturally preserves order in JSON. The order of the attributes in the document is not necessarily preserved. In fact, you'll often find that the attributes get resorted based on alphabetic order due to the way that JSON documents are optionally compressed on the server for storage or across the network for transmission performance. Arrays should contain homogeneous or similar objects. Use the Sesame Street song, one of these things is not like the other, as your guide here. So you guys are really good. We may even get Tyler to sing the song for us. If your documents are different from each other, they probably belong as distinct attributes or in separate arrays. Don't reach down into an array of objects and try to query out a subset of them based on some criterion without stopping and wondering if there was a better way you could have done that. Arrays and the documents inside them should be small. If you have more than 10 items or so in an array, start to ask questions of yourself. Not that that's a system limit or a best practice, just a point where I want you to start thinking about alternatives. If the documents in the arrays are not small, replace them with references to distinct documents and then use the key value API to fetch them as needed. And if you don't have a reasonable idea or assurance about how many items will be the maximum number in an array at design time, in other words, if it could be unbounded, don't use an array. Right? Think of another way, or ask us for some help on thinking of another way. All right, so you're probably reaching the saturation limit for useful tidbits. I do want to show you one more thing before the demo. As I mentioned before, the full text service has an unfortunately limiting name. It can do so much more than full text, so I want you to think of it as a different kind of index. Fully understanding when you might use a global secondary index versus a full text search index is a very advanced topic. It takes the understanding of how these indexes are represented in memory and on disk, which we don't really have time to get into here. The choice is also very dependent on your model of your data and the nature of your queries. So I'm going to flash this slide up here just long enough for you to grab it with your screen capture software. Tyler and I put this slide together, but as you might imagine, there's enough overlap between these two services that not everyone would agree with our recommendations as presented here. When it comes to arrays, it gets even more complicated. We've had a customer that has moved back and forth between GSI and FTS on the same document model as the nature of their queries and as the size of their data has changed. One has made more sense or better performed than the other. The lesson here is please ask for our input. We are more than happy to help since getting this right can have a big impact on the success of your project and we want you to be successful. Okay. Enough of me promising a demo. It's now my pleasure to hand this over to my colleague and friend, Tyler Denton.
One of these things is not like the other.
Oh, yeah. Back to the presentation. So, thank you, David, for that fantastic introduction. My name is Tyler Denton. I'm a solutions architect in the Couchbase Center of Excellence. And I'm going to demonstrate some of the things that David was talking about in the earlier conversation. Mainly some of the differences and similarities between Nickel and FTS. As David mentioned, the models that I have in this demo don't necessarily follow the best practices for data modeling. We have bad things like snake case instead of camel case, fully written out names instead of abbreviations, duplicate data in our nested objects, primary indexes, and things like that. While this is okay for development and demos, you wouldn't want to take something like that into production. For production, you would definitely want to use snake case, minimize your keys, fields, and values as much as is reasonable. Now, for the first demo, or for this demo, first we can tour our demo cluster. So here I have 4 nodes set up, 2 data nodes and 2 nodes running all the other services. So you can see query, index, search, analytics, and eventing. We have a couple indexes already defined. We have some FTS indexes defined. We have an analytics data set that are set up here. And we have some eventing functions that are built out. We're going to start this by looking at some of our data models. So let's go ahead and look for are two that we're going to focus on here, which is going to be, well, let's actually look and see what data models we have to work with. So this is just going to give us a list of the JSON types that are available in this bucket. And so we have transaction, product, shopping cart, and user. We're going to be focusing on the transaction and shopping cart models. So let's grab a transaction document. We only want to get one. So here's our transaction document. You can see we've got a billing address, some credit card information, an item list, which is what we're going to be working with. The JSON type is transaction, some information about the purchase date, which is important, our last name, shipping address, and some unique IDs and user IDs. Then we can look at our shopping cart. So this is much smaller, but it still has things like an item list. And here we have an updated date. So those are going to be our important information that we want to look at. So let's do some data mining of our database. I want to generate an item list of all item names in shopping carts and transactions for the first week. So the first thing that we would do, and let's make sure that I don't cheat, and let's drop some indexes here. Is we're going to issue a query that is going to use our primary index. And I'll walk through what this query does. So first, we're going to get the distinct names from our items that are in item list after being unnested from our shopping carts and transactions. And we're looking for things in the last 7 days based on our purchase date and updated date. So if we execute this, it's going to take a very, very, very long time. It's using a primary index. And so this is one of the reasons that we never want to have a primary index in production. If for some reason we were to, the index selector query planner was going to pick the wrong index and it sees that there's a primary index available, this could be a huge problem. So we're going to cancel that because we know that we don't want to do that. We're going to go ahead and we're going to build 2 indexes. So our first index is going to be for our transactions, and our second index is going to be for our shopping carts. Now we can issue both of those at the same time because we're working in Couchbase 6.6 as long as they're separated by a semicolon. You can see here we're doing a distinct array for item in item list and purchase date, and item in item list for updated date. And that's for transaction and shopping carts. All right, so our indexes are finished building. So now let's go back and issue that same query. All right, so that query took 18 seconds and it generated 7,665 results. So a lot of products have been purchased or included in a shopping cart in the last week. But let's see if we can get that performance a little better. The first thing that we're going to try is using a flex index. And so that's going to utilize our full text search. And so we can come here and look at this other index that I've defined. And it's using the default type mapping with purchase date and updated date. And then we have a child mapping of item list and name title. And normally you don't want to have a default type mapping, but in this case, we have to have a default type mapping because we aren't going to be able to specify the individual types to use a flex index. So remember, 18.5 seconds. Here, let's go and put this query in, where this query is going to say, select the item name title as name using FTS. And we're going to pass this information in here and we're going to execute. Ah, 8 seconds. So using Flex, we were able to cut that down by about, or a little more than half. Now you'll notice that we got a lot more records, and that's because of the ability of FTS to find additional records. We also have a little bit wider window here. But I think that we can still do better. And so now, instead of using the Nickel workbench editor, we're going to have to issue our SDK query from the REST API. We could also use the SDK. And so here we're going to end up using this index. And what this index does is this allows us to specify the transaction and the shopping cart, which are both different types, and put in the purchase date and updated date under each one of those types. And so we'll have our item list in here, and this will allow us to be very specific in the query that we execute. So here we can look at this and see the query that we're going to issue. So we're going to get the fields. We're going to pass back the item title. We're going to do the query with the disjunct of purchase date with the start and updated date with a start. We're not setting an end. We don't want to score, and we're setting a size that's large enough to grab everything. Then we're going to use JQ to pull back the hits and see how long it took. Typically, this is going to say took is in nanoseconds, and so we want to just turn that into seconds. So let's issue it. And it's already returning results. We're just having to process the data set, and there we are. The actual query itself took 0.45 seconds. The rest of that time, which if we come back up here, we can see that the overall rest of the time was right about 6 seconds. So that's 5 seconds spent returning our result, and the rest of the time was in the actual query processing. So this is considerably faster than our Nickel query running in using the array indexing. That is definitely some serious performance gains. And this is just one example of how FTS can greatly outperform Nickel when it comes to indexing and querying arrays. And realize at no point did we do any actual kind of wildcard matching or word stemming or things typically associated with full text searching. What we're doing here is we're just exploiting the unique way that FTS builds and scans its indexes. All right, back to you, David.
Thank you, Tyler. Now, just a couple of quick slides to summarize and wrap up. First one addresses the question of, what if I don't get my model right the first time? Well, the first thing to do is to reach out to Couchbase and ask for help. That's our favorite part of our jobs. We love to teach people how to get the best performance out of our product. Secondly, make sure you're understanding where the performance problem is before you try to fix it. Check out Tyler's session on using Prometheus and Grafana for system monitoring. Make sure that you are using the response time observability feature. There's a session on that. Or the client, as part of the client SDK, which gives you performance numbers from the client's perspective. This will let you know if the problem is in your client, in your network, or on your servers. Thirdly, you can use the index advice and the index advisor features in the latest releases of our product to make sure that your indexes are optimized for your queries. You can do that from the query workbench. It's very easy. And there is a very common pattern that when a client makes a SQL query to bring back a bunch of documents, especially with a select star clause, if you ever type that, I want you to ask yourself, do I need the whole document back? Could I use a covering index instead? And a covering index is a special kind of index that has all the information it needs to meet the projection statement of the SQL query. If you decide you do want the whole document, that's okay, but it's going to likely be better for a number of reasons, network considerations mostly, for the SQL query to return the meta IDs of the documents you want back to the client, and then have the client do a bulk asynchronous get to fetch those documents using the key value system. Trust us, it's better. And if nothing else works, think about creating your own materialized view that is optimized for your queries. We've done this for one customer who had a document model they didn't really want to change, and it wasn't meeting the performance needs of their queries. So we used the eventing service to keep the secondary data model synchronized with the changes that happened to the primary data model. It turned out to work very well, and the secondary model was really designed to meet their queries perfectly. And in the end, the performance and the storage wasn't significantly worse or different than creating a complex index. So it worked out well. And lastly, for my summary, I'm going to present this like a list of things that make you go, watch out for documents over 5 kilobytes in size. Anything larger than this, and you need to be concerned with how much data you're moving around your network for each operation. Secondly, beware of anyone who tells you to watch out for documents over a certain size. It's just not that simple. Wouldn't it be nice if it was? There are valid cases for violating that recommendation, and if you follow it blindly, if you follow any recommendation blindly, you could potentially do more damage. Thirdly, anytime you're doing fuzzy queries, you should probably think about using FTS. It's a lot better at that, and there are a lot of tools in it for optimizing fuzzy searches and what fuzzy actually means. Next, be aware of if every single query needs its own index. That's probably overkill. Our index advisor service will soon be capable of recommending when the trade-off between speed and resources might tip the balance to having a less than optimal index for every query and allowing multiple queries to share a single index. That's coming in the next release. I mentioned it not long ago, but it's worth repeating. Select star is a big red flag. Don't get me wrong, there are many valid reasons to do it, but should always make you think about returning the meta ID and then using the key value service directly from the client. The reality is that's what the query service is doing under the covers anyway, but the network patterns are much better if you do it yourself. And my parting words, which are so important, I'm considering having them etched on my tombstone, are that the solution to an SDK timeout is almost never to increase the timeout. Always, always, always use the tools that we provide to find the source of the performance problem before you attempt to fix it. Thank you so much for your time and attention and for your interest in Couchbase.